Yeah. Hi everyone, I am Aishwarya. Currently, I am pursuing BTech second year in Srinivasa Ramanujan Institute of Technology from the Department of Electronics and Communication Engineering. So, I decided to speak about 4 is to 1 multiplexer using Verilog. Basically, what does it mean? What is multiplexer? Multiplexer is a combinational circuit. It can store the data, and it reduces the complexity of a circuit. When we compare to other circuits, it completely uh, makes it easy. I mean, it is not complex. A 4 is to 1 multiplexer is a digital switch that selects one of four input signals based on two select lines. It means by the name, in 4 is to 1 multiplexer, in the name only represents there are four inputs and one output, and it has a two select lines. How does a select line select? I mean, we based on the principle 2 power n. It means 2 power n is equals to 1 means 2 power 1. It means a 2 is to 1 multiplexer. If we take 2 power 2, it means 4 is to 1 multiplexer. So that based on the 2 power n, the multiplexer uh, is based. Now 4 is to 1, it means 2 power 2, 2 power 2, 4 is to 1 multiplexer. It means it has two select lines, four inputs and one output. Based on the inputs, the select line select one input and it can form the output. It outputs the selected input signal to a single output line. It means not all are formed. It based on the single input. Only one single input is selected, and the selected input only forms the output. It happens four times. Because it is 4 is to 1, it means 4 inputs, one output. It can form only in individual times, not all. The device is widely used in digital systems for data routing and resource sharing. It is used in digital systems for data routing and resource sharing. You can observe that block diagram of a 4 is to 1 multiplexer. Uh, Previously I said that it has four inputs and one output and two select lines. You can see that in 4 is to 1 marks, x0, x1, x2, x3 are the inputs. C1 and C2, it means two select lines. C1 and C0 are the two select lines, and M is the output. uh, we we can say that by the select lines, if the select line selects x naught as a input, and it can form the output M. If the select line selects x1, it also form the M output. If the select line selects x2 as an input, it also forms an output M. If the select line selects x3 input, it can also form the output M. It is done by the individual only. Basic operation of a 4 is to 1 mux. The multiplexer uses select lines to determine which input to pass and to the output. The multiplexer, previously I said no, the select line, by the select lines only the input is selected, and which is to pass the output. I mean, which it selects the input line, and it can form the output. Only select line can select the input. When select lines are set to a particular combination, the corresponding input is connected to the output. It means when select lines are set to a combination, the corresponding is connected to the output. It simplifies the design of a complex digital circuits by reducing the number of data lines needed. Previously I said no, multiplexer can reduce the complexity when we compare to other circuits. Basically other circuit needs more number of data lines, but in multiplexer it can reduce the number of data lines. You can see the truth table. C1 and C2 are the select lines and M is the output. You can say that if it is 0 0, then the output takes the x naught input. If it is a 0 1, 0 and 1, the output will take the x1 input signal. If it is 1 0, then the output will take the x2 as the input signal. If it is a 1 1, the output x3 will take the input x3. The output m will take the x3 as an input signal. It can form the output. X0, x1, x2 are the outputs. C1 and C0 are the select lines which are responsible for the outputs. Basically by this truth table you can draw the logic diagram. It means C0 is C1 is 0, C0 is 1, so that first it is C0 is 0, both are 0, so that it is 0, and x0 is the input signal. It forms the AND addition, and 0 1, C1 is 0 and C0 is 1, and x1 is the output. It also forms the AND gate. 1 0, C1 is 1, C0 is 0, and x2 is the output. It also forms the AND gate. C1 is 1, C0 is 1, so that x3 is the output. It also forms the AND gate, and this all forms the what NOR gate. It means it all forms the addition. The addition means NOR gate. Finally the obtained one, last one is the output. Verilog hardware description language, HDL. Verilog is a popular HDL used for modeling and simulating digital systems. It allows the designers to describe the hardware, behavior and structure in a textual form. Verilog code can be synthesized into physical hardware or use it to be simulation purpose. Verilog can be used in physical hardware or simulation purpose, like Vivado, etc. Verilog HDL code. We can write the code. First of all, we need to write the module, and the module name is MUX. We are taking the 4:1 multiplexer, so that the module name is 4:1 MUX 4. There are 4 inputs, that is A, B, C, D, so that we represent the input A, input B, input C, input D, and input 1:0 S, and the Y is the output. We and again we represent the Y with in a register, so that res Y, and again we use the statement always @ABCDS. It is ABCDS are the inputs of the code, and we and next below that we use the begin keyword, and again the case statement. Case of S to B00 is to Y is equals to A, to B01 is to Y is equals to B, to B10 equals to is to Y is equals to C, to B11 is to Y is equals to D. It means if it is a 0 0, the output will take A as the input. If it is 0 1, the output will take B as an input signal. If it is 1 0, the output will take C as the input. If it is 1 1, the output will take D as an input signal. By default y is equals to a, and we end with the end case statement, and again end, and we start with the module name, and we also end with the end module. It is mandatory. Where we start, we need to end with that only. We start with the module mux name, and we end with the end module. Yeah, it is about HTML code. We can say that A, B, C, D are the inputs, and the output is the y, and we use the register y always by using the always statement. It means A, B, C, D are the inputs, and we write with the keyword begin, and we also write the case statement, and we write if it is 0 0 it is a, if it is 0 1 it is b, it is 1 0 is equals to c, it is 1 1 equals to d. By default y equals to a, and we end with the case state. We start with the case, so that we end with the end case, and again end we end with the end module. Design of the 4:1 mux in a Verilog. The design uses 4 input signals, 2 select lines, and 1 output. The module employs a case statement inside an always block to control data routing. Proper port declaration and case handling ensure correct functionality. Uh, if you write the code without any errors, and if you run the code, then it generates one output, and also the RTL schematic of a 4:1 multiplexer. Test bench design for simulation. The test bench insulates input signals and simulates different select line combinations. It applies test vectors to verify the correct output behavior of the mux. The simulation helps identify and logical errors before hardware implementation. Simulation results and waveform analysis. The simulation displays waveforms showing input signals, select lines, and output. The correct functionality is confirmed when the output matches the selected input for each case. Analyzing waveforms ensures the multiplexer operates as intended under all conditions. So previously I said no, if you follow the code without any errors, and if you run the code, the output is generated in a Verilog. So if you give 0 0 input, it results in a. If you give 0 1 as an input, it results in b. If you give 1 1 1 0 as an input, it results in c. If you give 1 1 input, it results in d. By this you can you you can follow that multiplexer follows the code, and in Verilog, and through the code only the output is also generated. Where do we implement this? Implementation tools in and environment. Popular tools like Model Sim or Vivado. We use this in Vivado or Model Sim to compile and simulate the Verilog code. The simulation environment provides a graphical interface to observe waveform and debug. Synthesis tools convert the Verilog design into hardware description for FFGA or ASIC implementation. Uh, Basically, it is used in ICC implementation, hardware description, and electronic devices. Applications of a 4:1 multiplexer used in digital systems for data routing, resource sharing, and signal selection. Employed in processor architecture for instruction and data multiplexing. Essential in communication systems for channel selection and data multiplexing. Conclusion and future scope. Finally, I conclude that the Verilog based design and simulation of a 4:1 multiplexer demonstrate fundamental digital design skill. Extending this approach can lead to designing larger multiplexer and complex data selectors. Future work includes integrating multiplexers into larger systems and optimizing for speed and area. Thank you.